Take the unit 5 applications. Take the topic Bruijn sequence and Bruijn digraph and Poset and Hasse diagram. First basic terms. First one, Euler graph. A connected graph G is called an Euler graph if there is a closed triangle which includes every edge of the graph G. So next, Euler path. An Euler path is a path that uses every edge of a graph exactly once. Next point, an Euler path starts and ends at the different vertices. Next, Euler circuit. An Euler circuit is a circuit that uses every edge of a graph exactly once. So next point, an Euler circuit always starts and ends at the same vertex. So next point, a connected graph G is a Euler graph if only if all vertices of G are of given degree, and a connected graph G is Eulerian if only if the edge set can be decomposed into cycles. Okay, the first one enna Euler graph. Euler graph and is a first of all graph is a connected graph. Okay, if there is a closed triangle, okay, closed triangle which includes every edge of the graph G. Okay, closed triangle means start and end will be both same. Okay, start and end will be both same. Okay, in every edge. So next, Euler path. Euler path is the first of all path. So start and end both are different. Okay, so the path uses every edge of a graph exactly once. Edge வந்து எப்படி இருக்கணும் exactly once. Okay, ஒரே ஒரு டைம் தான் வரும். Okay, next Euler circuit. The first of all, Euler circuit is a circuit. Okay, so the circuit means a cycle. So start and end the both is same. Okay, same. Okay, same vertex. So next, and a connected graph G is an Euler graph if only if it all vertices of G are of degree even. So and a connected graph G is Eulerian if only if the edges set can be decomposed into a cycle. So in the last point enna appadina நம்ம தீரத்துக்கு அப்ளை பண்ணும்போது we can use the result. So this is the example for the Euler graph. We can see the above graph is Euler graph as start the vertex A 1B 2C 3D 4E 5C 6 F 7G covers all the edges of a graph. So எல்லா edgesயும் cover பண்ணிருச்சு. So this is the example for the Euler graph. So next, Hamiltonian graph. Hamiltonian graph, the first of all a graph as well as a connected graph. So a connected graph G is called a Hamiltonian graph if there is a cycle which includes every vertex of G, and the cycle is called a Hamiltonian cycle. So Hamiltonian cycle enna paakra poromna, first is a cycle. Cycle is a closed start and end vertex both are same. Okay, the Hamiltonian walk in a graph G is walk that passes through each vertex exactly once. This is the important point. So through each vertex exactly once. So Euler path நம்ம என்ன பார்த்தோம்னா every edge exactly once. Okay, Hamiltonian pathல என்ன பண்றோம்னா the each vertex exactly once, the both be the difference. We can see the example. Okay, we can see the example. This is the Hamiltonian graph. So next பார்க்கிறது என்ன Bruijn sequence. The Bruijn sequence B of k, n is a cyclic sequence of a given alphabet A with size k, for which every possible subsequence of length n appears as a sequence of consecutive characters exactly once. Okay, here the size k, so length is n. Okay, and the Bruijn sequence is B of k, n. The subsequence of length n appears as a sequence of consecutive characters as exactly once. Okay, so next this is the alphabet 0, 1. So subsequence of length 2, the subsequences, okay, 0 0 1 0 0 1 1 1. Okay, so 4 subsequence is available. So length வந்து நமக்கு என்ன சொல்லிருக்காங்க அப்படினா 2 ன்னு சொல்லி கொடுத்தாங்க. So அதை பேஸ் பண்ணி நம்ம என்ன பண்ணிருக்கோம்னா 4 subsequences கொடுத்திருக்கோம். So we form the Bruijn sequence 0 0 1 1. 0 0 1 1. Okay, so we can see the colors yellow 0 0, we can see the color green 1 1. So we can see the color red 0 1. This is the de-Bruijn sequence. So next we can construct the sequence. So first point, to construct a sequence B of k comma n, we compute an Eulerian cycle of n minus 1 dimensional de-Bruijn graph over k simples. So next point, in a graph theory, an n-dimensional de-Bruijn graph of k simples is a directed graph representing overlap between the sequence of simples. So next point, it has an kn vertices consisting of all possible length n, the sequence of given simples. So last point, a direct edge is drawn from vertex v1 equal to si etc. si plus 1, si plus n minus 1 2. So v2 sj, the running from sj plus 1. If the simple si plus 1 is identical to sj, the simple at si plus 2 is identical to sj plus 1, and the simple at si plus n minus 1 is identical to sj minus 1 plus n. Okay, well, we can form the identical value. Okay, well, the main point of the last one, we can the same value si plus 1 that corresponds to sj. Okay, si plus 2 that corresponds to sj plus 1. So si plus 1 n minus 1 is identical to sj minus 1 plus n. Okay, next, de-Bruijn graph properties. The first one, if n equal to 1, all the vertices are connected forming a total of k to edges. Okay, so next one, each vertex has exactly k incoming and k outgoing edges. So next point, the n minus 1 dimensional de-Bruijn graph with the same set, each n dimensional de-Bruijn graph is the line diagram of simples. So next one, that each de-Bruijn graph is Eulerian. What that means, it has an Eulerian circuit visiting every edge exactly once. Already in the basic terms we can recall the definition. So next, each de-Bruijn graph is Hamiltonian. That means it has an Hamiltonian path visiting every vertex exactly once. Already we can see the basic terms. We recall the definition. Okay. So next, the Euler cycles and the Hamiltonian cycles of this graphs are de-Bruijn sequence to an edge of the n minus 1 dimensional de-Bruijn graph, and each vertex of the n dimensional de-Bruijn graph correspond to two edge path in the n minus 1 n dimensional de-Bruijn graph. This is the graph for the de-Bruijn graph properties. Okay, de-Bruijn graph properties, we can see the properties. So first one is 0 1. Okay, 0 1, we take the alphabets. The second one, the red color, so we can form the subsequence. 0 1, again 1 1, 0 0, 1 0. Okay, the third one is, okay, we can change the identical values. Okay, when the 0 0 1, the self loop, again 1 1 we can self loop, and again, so we form the another way. Okay, so we can form the another way. So then the next one is, so the third one, so 0 0, we can mingle the values. Okay, we can mingle the value. Again the fifth one, we can see the diagram. Okay, so we can develop the sequences, subsequences. Okay, first நம்ம என்ன எடுத்துக்கோம் அப்படினா 0 1 சொல்லிட்டு தான் எடுத்துக்கோம். So again அடுத்த ஸ்டெப் பாத்தீங்க அப்படினா the 4 values. Okay, so again அடுத்த ஸ்டெப் வந்து 4 values, we can develop the values of 4 and then நமக்கு 8 எப்படி சேஞ்ச் ஆயிச்சு, 8 ன்னு சேஞ்ச் ஆயிச்சு. Okay, so again 8 ல இருந்து again 8, so அந்த 8 இந்த எப்படி நமக்கு சேஞ்ச் ஆகுறதுன்னு அப்படின்றத உங்களுக்கு கொடுத்திருக்காங்க. உள்ளே நீங்க பார்த்து we can see the example, எப்படி வந்து ஸ்ப்ளிட் ஆகுது, so எப்படி வந்து எக்ஸிஸ்டிங் கேஸ் அடுத்தது வருது அப்படின்றத கொடுத்திருக்காங்க. So we can see the example. So next, this is the graph. Okay, this is a de Bruijn graph for the all possible doublets. Okay, de Bruijn graph, the all possible doublets. We can see the example. Okay, we can see the example by we can the letters. We can form the letter, the AA, AG, GA, GG, AC. So we can the letters. So in the dark line, the center of the point is the dark line, AT, CC, again CG, TA. Okay, so in the second graph we can see. So we can form the circle, we can form the cycle. Okay, so center of our cycle irukku, so outline the cycle irukku. So we can the another third graph we can develop the DGCCGA. Okay, TGCC. Okay, CA. So again the next one ATAACT. So next one, so CGATAA. So next one ACTGCs. Okay, so we can see the example. So the de Bruijn graph for all possible doublets. Okay, we can see the example. So next, the partially ordered set, that means a Poset. This is the discrete mathematics. Okay, this is the discrete mathematics of the partially ordered set, that means Poset. So the first point, a partially ordered set consists of a set. The first of all set. The set means set of all well-defined object. The object well-defined means AP may in present, in future. So AP may change, no change. Okay, no change. In the example, the set of all alphabets. So AP may change. Set of all numbers, no change. In present, in future. Okay. So first point, a partially ordered set consists of a set with a binary relation which is a reflexive, antisymmetric and a transitive. Okay, the partially ordered set is observed is a Poset. So நம்ம என்ன பண்றோம்னா observe it as a Poset. Okay, so 3 points. So reflexive, antisymmetric and a transitive. Okay, the example, the set of real numbers under the binary operation less than or equal to. That means less than is a Poset. Let the set S is equal to 1, 2, 3 and the operation is less than or equal. The relation will be 1, 1, 2, 2, 3, 3, 1, 2, again 1, 3, 2, 3. This is the relation. We can see the example. Okay, so Poset means enna condition first one is a set with the binary relation. Okay, reflexive, antisymmetric, transitive. Okay, so the next this relation R is reflexive. So reflexive means reflection. Okay, apna eppadi irukum appadina அதுக்குள்ளே தான் இருக்கும். ஸோ 1 எடுத்தீங்கன்னா அதோட ரிஃப்ளெக்ஷன் எப்படி இருக்கும் 1 தான் இருக்கும். 2 எடுத்தீங்கன்னா 2 அதோட ரிஃப்ளெக்ஷன் 2 ஆக இருக்கும். 3 எப்படின்னா அதோட ரிஃப்ளெக்ஷன் 3 ஆக இருக்கும்னா 1,1, 2,2, 3,3 belongs to R. Okay, so next this the relation R is antisymmetric. So antisymmetric means என்ன அப்படின்னா so both relation 1,2, 1,3, 2,3 belongs to R and 1,2, 1,3, 2,3 not belongs to R. This relation R is also a transitive. Okay, transitive means enna appadina 1,2, 2,3, 1,3. Okay, 1 la 2, 2 la 3, 3 la 1. Okay, belongs to R. Hence it is a Poset. Okay, so the vertex set of a direct acyclic graph under the operation is a Poset. So next Hasse diagram. So first point, it is possible to associate a graph called a Hasse diagram. So with the partial order relation defined on a finite set. Okay, the partial order relation defined on a finite set. The first one, to obtain Hasse diagram, proceed as follows. The first one, start with a direct graph of the relation, placing vertices on the page so that all arrows point upward. Okay, then eliminate first one, the loops all the vertices. So second one, the all arrows whose existence implied by the transitive property. The third one, the direction indicator and the arrows. Okay, well, we can draw the Gauss diagram. We can use the 3 points. So example, the say subset relation on the set a comma b comma c that is for all sets u and v in a comma b comma c. We can construct the Gauss diagram for this relation. Solution: draw the directed graph of the relation in such a that all arrows exert the loops in the point upward. So we can see the example. So எல்லா பாயிண்ட்ஸ் பார்த்தீங்கன்னா we can the upward the arrow mark பார்த்தீங்கன்னா எல்லாமே அப்ல இருக்கும். Okay, we can see the example. எந்த ஒரு வேல்யூ எந்த ஒரு பாத்துமே வந்து கீழே பாட்டத்தில் வந்திருக்காது, எல்லாமே அப்ல தான் இருக்கும். We can see the example. Okay, next, the strip always the loops unnecessary arrows and the direction indicate to obtain the Gauss diagram. Okay, so அதெல்லாமே நம்ம என்ன பண்றோம்னா we can delete the self loops, arrows, diagrams. Okay, so எல்லாமே delete we get the answer of Gauss diagram. We can see the example. The first one, the bottom empty. The second one A B C. Okay, the second is the kila below the above bottom to top. Apna A B C. So we conclude A, the first set A B um eduthenga A B. So first A B vandrum, again adutha A C. Okay, the second one, again third one enna A B C. Okay va, again last top of the we can use all the values A B B C A B BC again AC. We can use all the set. We get the answer A comma B comma C. Okay, we get the answer A comma B comma C. So நம்ம empty set ல எடுக்கிறோம். Again we can single set, again the double set, again and the triple set. So இப்போ எல்லாம் the first இந்த last set நம்ம எடுத்துக்கிட்டோம்னா இந்த செட்ல கீழ இருக்க எல்லா வேல்யூஸ்மே எக்ஸிஸ்ட் ஆகும். ஓகே, அந்த மேல இருக்க செட் நம்ம எடுத்து ஃபர்ஸ்ட் செட் A B C எடுத்துக்கிட்டோம்னா அந்த டூட் இருக்கிறத ஏபிசியும் அதுக்குள்ள வந்துடும், ஏசியும் அந்த செட்டுக்குள்ள வந்துடும், பிசியும் அந்த செட்டுக்குள்ள வந்துடும். அதே மாதிரி ஒன் சிங்கிள் எடுத்துக்கிட்டோம் ஏபிசி எடுத்தோம் கண்டிப்பாக அந்த மெயின் செட்டுக்குள்ள வந்துடும். ஸோ எம்டியும் அஸ். ஓகேவா? ஸோ வி கேன் சி த எக்ஸாம்பிள்.